All right, welcome back, everybody. Today we are going to be talking about QR1, which is solving quadratics. A QR just is basically our quadratics review unit. So we want to go through, we want to hit on some points here and make sure you understand as much as you possibly can about these quadratics, because that is going to be so important for you as you move forward to your next math class. So here's our first equation. It says solve each equation. Now, the way you want to go through and solve this is your goal, is ultimately to get x all by itself. Now, when you see a problem like this, normally a good rule of thumb is to try to get everything onto the same side. So we are going to add 1 to both sides to make that happen. So now we will have plus 1 equals 0. Now, when you get to this spot, there's normally two strategies to solve something that looks like this. And when I say something that looks like this, I mean something that's going to have an A, a B, and a C. Now, one of those ways is to solve this by factoring. But if we try to do this by factoring, and this is really trial and error to see if this works at all, excuse me, when we try to actually factor this, 1 times 1 would give us a 1 up top, and we'll get a negative 4 on the bottom. So we need two numbers that multiply to be 1, that add to give us a negative 4, and pretty quickly we're going to figure out that that's not even possible. So in this situation, factoring is not possible. Now, hopefully you get to a spot and you get POSSIBLE. Hopefully you get to a spot where you look at these things and you can say pretty quickly that it's not going to be factorable. Now, if it is not factorable, then your other method is the quadratic formula. So let's look at this first one. So if I wanted to try the quadratic formula, A would be 1, B would be negative 4, and C would be 1. So when I do my quadratic formula, remember that's negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So let's just replace. Every time I see a B, I know B is up here is negative 4, so I'm going to replace my B's with negative 4s. I know my A's are just 1, so anywhere I see A's, I can replace those with 1. So I'm going to get rid of my A's. I'm going to put in my 1's. And I know that C is also 1, so I'm going to put a 1 in over here. Now, when I go through and I actually solve this thing, negative 4 is going to turn into a positive 4, plus or minus the square root. Remember, the square root's the hard part, all over 2, because 2 times 1 is 2. And then we just grab our calculator, and we let our calculator do the lifting for us. So to do that, that pad is slow. Real slow. Okay, there we go. So now let's just look at whatever's inside here, and we just want to evaluate that. So parentheses, negative 4 to the second power. Remember, those parentheses there are extremely important. Minus 4 times 1 times 1. And you end up getting 12 on the inside. So we have 4 plus or minus the square root of 12. So let's just evaluate and figure out the square root of 12. Hey, look, that is 3.46. So I'm going to erase this, and I'm just going to replace it with what it's equal to, 3.46. So to get my two answers, I'm going to have 4 plus 3.46. Get that answer. Divide that by 2, which is the bottom here. And one of our answers is x equals 3.57. And then to get the other answer, I want to do the minus. So I'm going to do 4 minus 3.46. Take that answer, divide that answer by 2, and you get 0.27. So my two answers here will be x is equal to 3.57 and 0.27. Now, looking at problem number 2 over here, this appears to be a good problem as well. And the reason this one is good is because this one does not have an x term. Does not have an x term. Now, what I mean by x is just x. This one has an x squared, but it doesn't just have the single x term. Now, the reason that's beneficial to us is that when we have something like this, we can actually easily solve this by just getting the x squared alone. So to do that, I would divide by 5 and divide by 5. These two cancel out. You're going to have x squared is equal to 25 divided by 5, which is 5. And then, of course, to just undo the square root, to undo squaring, we just need to take the square root of both sides. So doing that, these two pieces cancel each other out, And I'm left with, now this is where we got to be careful. Whenever you take the square root of just a number, you got to remember that you always introduce a positive and a negative version of that. So by taking the square root, we should say plus or minus the square root of 5. Now, sometimes we may write that as a decimal, and if we did, we would just do second square root of 5, and we'd find out x is equal to a positive 2.24. And then since there's also a negative, we would say x is equal to a negative 2.24. We really get both answers that come out when we do that. And that kind of makes sense in our brain because remember, quadratics almost always have two answers to them. Here's another problem. Now, I just want to get you started on how I would go about solving this. I'm not going to actually solve this one for you. In this problem, let's just get everything onto the same side. That should always be our start if we notice there is a single x term. So I'm going to subtract 14 from both sides. Minus 14 equals 0. And over here, the way I would suggest trying to solve this is I would say, well, let's just see if we can factor it. You should always try to factor. It's easier than doing the quadratic. Heck, I'll do this one with you too. So remember, we would say 1 times negative 14. That's going to go up top. We'll put a negative 5 down on the bottom, just like that. We'll have 1x over, 1x over. Can we find two numbers that multiply to be a negative 14 that add to give us a negative 5? Thinking that over, hopefully pretty quick, we come up with, how about a negative 7 and a positive 2? Negative 7, positive 2, I think make this work. So that would mean our factored form would be 1x minus 7 and 1x plus 2. Now this is officially equal to 0. Now to finish solving this, our directions were not to factor it, our directions were to solve. To finish solving this, the way we do it is we take this term and we set it equal to 0, and then we take this term and set it equal to 0, and we write two new equations. So 1x minus 7 equals 0, and 1x plus 2 equals 0. And then we solve. So add 7, x equals 7 is one of our answers. Subtract 2, x equals negative 2 is our other answer. Now, one thing to know about this, guys, is that solving by factoring will not always work. We saw a great example of that up here where factoring was not possible. If that happens, then your attempt or your approach has to be the quadratic formula. It's important to know the quadratic formula will work on any problem. It would have worked even on number 2 there. It will work on absolutely everything you ever encounter. Just takes more work, so it's nice to know those workarounds. So on number 4 here, I would suggest you should try to factor this if possible. If you find out it's not solvable by factoring, then do the quadratic formula and you should also get to the same answer. If you're looking at problem number 5, 6 is pretty much the same. 7 is like number 2. 8 just has a lot of simplifying. So here's what I'm going to do. I'm going to help you through number 5, and we'll briefly touch on what to do on problem number 8, and then the rest will be up to you. So coming over here, this one is unique because the part that's being squared is this whole quantity. Now, in order to do that, or to get rid of this, we need to first start by getting rid of the squared part. The squared part's all alone. You can't pull out that 13 because it's all being squared. So we're going to start by square rooting both sides. Now remember, the square and the square root undo each other. So you're just going to be left with x plus 13 is equal to, now over here we square rooted 25. So that's going to give us a plus or minus. And then the square root of 25 is just 5. So now this is the part where we need to break this into two separate problems. One of them will be with the positive 5. The other one will be with the negative 5. So I'm going to get x plus 13 equals a positive 5. And then I'm going to get x plus 13 equals a negative 5. Now we just solve. So let's subtract 13 on both sides. We get x is equal to, it looks like negative 8. On the other side, subtract 13 on both sides, we get x equals negative 18. Right? So that is our process on something that's unique like that. Now, 6 and 7, I think you can handle based off of what we've already done. Number 8 does look confusing. So here would be my advice to you. If you ever encounter a problem that looks like this, get everything onto the same side. Normally, you try to bring everything over to the side that has more x squareds. So 3 is more than -2, so I'm going to move all of this stuff over to the other side. Now, here's how we do that. So we're going to add 2x squared to both sides and subtract 5 from both sides. So I'm going to add 2x squared and subtract 5. These two pieces cancel each other out. 3x squared plus 2x squared, that of course gives us 5x squareds. Our minus 10x drops down, and then our minus 5 sits over here, and we're equal to 0. And remember, once you are equal to 0, then you can attempt to solve this by factoring. If factoring doesn't work, you should be using the quadratic formula. Thank you guys so much for watching the full video. I really did try to keep this short and sweet so that you can get in here, get done what you need to get done, and hopefully make some progress. Remember, we're just reviewing the skills that we've previously learned. Thank you guys so much for watching the full video. If you have any questions, make sure you're reaching out and asking. Thanks, everybody. Have a great day.